I'm Xin Cui. I'm assistant professor at the Department of Chemistry at Mississippi State University. This is our research home and the lab. So I'm gonna show you our research labs and my office. So this is the research lab that we make the molecules. This is our group member, Niraj. He's a third-year graduate student. Here's some facilities that we're doing our research daily in. This is Chiral HPLC that allow us to separate the enantiomers. Some of our catalytic systems actually need a quite a strict air and moisture-free system. I was originally from China. I had my early education there in chemistry particularly, and I had my BS degree and a PhD degree from University of Science and Technology of China before I served as a research staff and faculty at the University of South Florida. Then I moved to Mississippi State University, started my independent career. So I find myself fascinated by chemistry since when I was in middle school, and then during the process attending the Olympiad Games of Chemistry. And then I just get addicted to particularly organic chemistry. Later catalysis, I want to have my own contribution to this field and to provide some new methods for people to make molecules. It's a very nice platform, including the infrastructure from the department and the college and the university for my research program to grow here. My department is the Department of Chemistry, actually focusing on the research and education in several disciplines of chemistry, like organic chemistry, inorganic chemistry, physical, analytical, and computational, and many new disciplines that is across the field of chemistry. I like here to have the opportunity to work with students from different backgrounds and coming working with us, which really makes our life exciting here as a researcher and a teacher. The research in my group focuses on catalysis, and we are motivated by asking questions like how can we create new ways and more effective ways to make molecules that can be used by human, particularly pharmaceutical molecules. So we are using catalysis as tools to generate these new methods and hoping our molecules can be future potential drug molecules or the core structures of them. Yes, we are working on a broad spectrum of methods and the target molecules, and so we're looking at the heterocycle compounds, particularly with multiple nitrogen atoms, and we're working on converting like the bulk and commodity chemicals from petroleum or renewable resources and directly convert them using catalytic methods to value-added small molecules and fine chemicals. Because out of our commodity resources from the earth, we have so much abundant of those chemical bonds, and how to do chemical operations to make them work and convert it into the molecules that we want is almost a perpetually pursued topic, and we want to get further into that. Okay, so in the past couple of years, we have been working on developing a technology that is called a asymmetric CH functionalization reaction. So specifically, we use these new catalytic systems to generate chiral molecules that could be used for drug candidates. For example, we established a asymmetric synthesis of enantiomerically enriched endolin compounds, which are important for many biologically active molecules. And more importantly, we think is that these methods that we developed could be more broadly used for other type of molecules. So we always try to look at whether our methods and catalytic systems potentially would be favored by the real pharmaceutical industry to use. And also we try to ask the question whether we can develop our methods more practical, that for either chemists or engineers that from different disciplines are able to use our methods in a more convenient way. Challenges associated with the nature of so-called enantiomers because to differentiate different enantiomers, it's naturally so challenging. The differences are very small. So design catalytic systems that are able to differentiate such small differences, which from energy-wise, structure-wise, even spatial arrangement-wise are so similar, are of great challenge. And we have done a substantial amount of detailed work, not only hope to find the new method that can do this, but also we want to be able to figure out a trend, a theory that would guide us for further development along this line. I think we're lucky to be here, have a very caring and a supporting culture from the department and up, and also the infrastructure and the facility here really set up a very solid foundation for us to do the work in the speed that we believe nowhere else can compete.